Okay, ladies and gentlemen, here is the second video. I promised you guys. We're going to try to do some differentiability derivative formula actually examples. And you guys notice we went through an introduction of such. So we went through an introduction. And so essentially the question is going to be, right, to determine the derivative. And we have formulas now. So I'm going to start off and keep it simple. And of course, we're going to use the notation we worked on and looked at the other day. So they want us to differentiate this function here, by the way. If we use operator notation, my favorite notation, they're really saying, can you differentiate the square root of 2? Now, remember something important here. You got to know something about this, right? The square root of 2, ladies and gentlemen, is an irrational number. It's a number, so it's thought of as a constant, right? It's not thought of, it is. And you know the derivative of a constant by the formulas is 0. You don't have to bring and use the definition anymore. You're using formulas and the facts that we talked about in lecture. So, you know, they can trick you with a question like that as a comparison kind of situation. You might say, what if they give me, Mr. Judge, a function is the cube root of maybe 6. And you go, huh. You have to know what you're looking at. What's the cube root of 6? Cube root of 6 is 0. And you say, why? Because the cube root of 6 is another constant. It's a number. That derivative is 0. Okay, so here's some examples. Now, what if they give you a function and they say, here you go, here's the cube root. Now you can say, I know what the cube root is. And it doesn't look like that, but okay. You're going to differentiate now. Derivative of x to the 1/3 power. Okay, here's what you guys do. You're going to use again the power rule. You say the power rule, yeah, and I'm going to use the highlight that like I did the other day. See this number? There's the power. You're going to write the power, and you're going to write times x, the power minus 1. Now remember what the power was. The power is 1/3. And so this is 1/3 x to the 1/3 minus. Remember what 1 is. You're going to have to write 1. You're going to have to multiply that by 3/3 to represent that. One-third x to the minus 2/3 power. Now, you have to write this with a positive power, and so that's 1/3 times x to the positive 2/3 power. So you're going to have to really focus on this here. X to the 2/3. 1/3. Remember that definition? This is the cube root of x squared. And I guess if we want to write this all in black here, right? F prime x 1/3 cube root x squared. And you're done. So compare and contrast. They can give you a cube root, right, where there's a number here, and that's really a constant, and the other is a function, variable. X varies. Okay, ladies and gentlemen. Examples, 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 right? You guys wanted them. Here you go. We're now going to kick it up. Right? You got a function here. Let's kick this up. It's 5x to the negative 6 power. So to differentiate this, we get 5x, negative 6 power. We're going to pull out the constant, right? Remember? You can pull out a constant. There's the constant. Now then you say, what do I do over here? You're going to use product rule. That power is negative 6. So power rule says, here's that negative 6, x to the power minus 1. So this is times negative 6. Don't forget that's negative 6 minus 1 here. So you got negative 30 x to the negative 7th power, because you did some arithmetic here, right? Negative 6 minus 1 is negative 7. So this will be negative 30. We write as a positive power. That's x over 7. So ladies and gentlemen, here is your answer. You say f prime x becomes negative 30 over x to the 7th. And there it is. Okay, that's number 4. Let's do number 5. And, you know, I'm just numbering these examples, so don't say, hey, Mr. Judge, where do we get these? And I'll tell you, well, you don't. I'm making it up. And this is, you know, 6 times an exponential x to the minus 3/2 power. So it's not found anywhere at any book. I'm kind of looking at your book and making up these examples on my own as we go along. So here's something similar to the prior one, meaning there's a constant. Use the property. The derivative of a constant is the constant times a derivative. We are in operator notation, my favorite notation. Here we go. And then now we say we use power rule here. And by power rule, we get 6. What's the power now? You get negative 3/2. You get negative 3/2 here. X to the, what's the power? Negative 3/2, right? Minus 1. So that's negative 3/2. Negative 3/2 minus 1. So this is 6 times negative 3/2 x to the, let's kind of keep it clean here, okay? Now this is going to be arithmetic. Replace that 1 with 2 over 2 because you're going to have to subtract some fractions up here. Here's what I'm saying. For the variable, right? But you also have to know how to multiply a whole number with a fraction. So you can say, Mr. Judge, is that, can I simplify this now? Yeah, 3 times negative 3 is negative 9. And this is now x to the negative 5/2 because negative 3 minus 2 is negative 5. We write this as a positive power, x to the positive 5/2. And you're pretty much done. You can now say, you know, f prime x is negative 9 over x to the 5/2 power. And here's an acceptable answer. But, you know, you may look in back of the book, and I want you guys to know some of this stuff because, like I said, it's good to, you're kind of reviewing arithmetic and algebra in a calculus course. You know, and we can actually simplify this, and here's a nice way to do that, right? You might say, can I write this as the square root of x to the 5th? Because remember here, you have an index. It's the denominator. That's your index. It's 2. These are rational exponents. You also have a numerator here. 5. It's right up there. And you have to simplify this. Now, my intermediate algebra students simplified these radicals. Now, there's a way to do it, but let me show you guys a shortcut. Here's a shortcut. You guys want to know this. 5 halves is really 2 going into 5. It goes in twice. Has a remainder. So what I'm saying to you is we can write 5 halves as, here's the quotient, 2, write it as a mixed number. Here's a remainder. This is your mixed number format. And remember something here, that this is 2 plus 1/2 by definition. Now, that's the 5 halves power here. So what I'm going to do now is this. I'm going to remind you. X to the 5 halves is really x to the 2 plus 1/2 power. And by properties of exponents, x to the 5 halves is really x squared, right, times x to the 1/2. So you have x squared square root of x. This is a way to simplify. Now, what I show here, the intermediate algebra students, is you say, okay, give me the largest perfect square that goes into x to the 5th. Here's your quotient. Okay, use product rule for square roots. Square root of x to the 4th is x squared, square root of x. This is the traditional way. But for me, I use the shortcut by simply doing my, writing an improper fraction as a mixed number. And that's, and then using your property of, from algebra, giving algebra that, an exponential to a sum, you can actually, separate those terms, a sum, right down here, right? You get the same thing. So you may say, well, which one do I use? And I'll say, you want to get used to doing both, because eventually, you can look in back of the book and you're going to say, I wonder how they got the answer of like -9 over x squared square root of x. All they did was the simplification, or simply writing this rational exponent as a radical. And you might think you did something wrong, and you really didn't. You did everything correct. Okay, so I want to show you guys some of these examples here this morning, because there's a lot of good detail here for you guys, so you guys can feed on this weekend, I hope. Feed on derivative formulas. Don't wait till the night before thinking you can watch these things before a test, right? And you go, oh, I can do this the night before. Not really. All right, let me do something like this. Here's another question. You might say, what if they give me 1/2 x to the 3rd power? And you say, okay, do I need to differentiate, that 1/2 x to the 3rd power? And you do, because that's the function they gave you, right? But what I want to remark to you about here is, in some of these questions that look difficult to do, the idea is to use algebra first, right? Use algebra to simplify. And that's the idea. Okay? And what I mean by that is, get rid of this portion, okay? If you have 1/2 x to the 3rd power, remember by beginning algebra, that's 1/2 to the 3rd power, x cubed, which is 1/8 x cubed. So just by doing some simplification using algebra, you are now able to take a more, scary kind of question and you now get 1/8 x to the 3rd power here. We can now differentiate. So pull out your constant again. And we get 1/8 d dx of x to the third power. Here's where we use power rule. 1/8. Now remember power rule? You said, I think I know what that is. You power x power minus 1. And this is 3 and 3. So you end up here with 3/8 x to the second power. And notice there is no simplification of this. This is 3/8 x to the second power. So you're done. So notice how this is just essentially all the properties that we went over. All the properties that we did, you know, in this lecture here. So you got some examples. Just looking. All right, here's a good example. F of x is maybe, pi over x to the fifth power. Okay, so we have to differentiate pi over x to the fifth power, right? Now remember what you have here. Pi is a constant. You get to pull out all the constants. So you have pi, the derivative of 1 over x to the fifth power. So we pulled out the constant. Derivative of a constant times a function is a constant times the derivative of the function. So remember, we're going to have to use a bit of algebra, even if it's beginning algebra. So you're going to write 1 over x to the fifth as x to the minus fifth power, which is pi differentiate x to the minus fifth power. All right, good. Don't forget, you got your constant here. And we're going to now use, as you guys can guess, power rule here, right? So we got pi now. Power x to the power minus 1. Negative 5, right? That's still negative 5. So you're going to get negative 5 pi x to the negative 5 minus 1. Negative 5 pi x to the negative 6. You did some arithmetic. Now you're going to write this here with a positive power. That's 1 over x to the positive 6 power. You're using beginning algebra, ladies and gentlemen. Remember that? Now it's positive, using the properties of exponents. And now we're multiplying a whole number or a whole term times a fraction. Negative 5 pi over x to the 6. So here's what you end up with. F prime x is negative 5 pi over x to the 6. And there it is. Okay, let's kick some of these things up, ladies and gentlemen. Let's get some more. What number are we up to? 7. Let's kick this up. Number 8. Let's say they give you f of x now is the cube root of x plus 2x minus 3. I don't know. Maybe we would just keep this out right now. All right. Okay. differentiate. Cube root of x plus 2x. Now the cube root of x to the 1/3. Right? And now you say, oh, we had that sum rule. Derivative of sum is sum of derivatives. It is d dx x to the 1/3 plus d dx 2x. All right. What do you do here? Well, I can say here we're going to use, for the first one, we're going to use power rule. For the second one, you know, we can do a little more. Pull out the constant. So for the second one, you have 2 d dx of x. And then what happens with this derivative? It's 1. So that work is done. 1/3 x to the 1/3 minus 1. I'm using power rule here. So I'm going to try to transition now, since you've seen some of these colors over and over again, right? So you get 1/3 x to the 1/3 minus 1 plus 2, and then don't forget 3/3. 1/3 x to the negative 2/3 plus 2, and this is now writing as positive powers here, ladies and gentlemen. 1/3 x to the positive 2/3 plus that 2. And I'm going to go a bit further. So this will be here for you. F prime max is 1/3 cube root of x squared plus 2, ladies and gentlemen. So I'm going to use, again, the definition of right here. An irrational exponent, right? 2 power. This is my index 3. That's why it has a 3 index and a 2 power. And now this radical is simplified because the index is bigger than the power for your variable. So there you go, ladies and gentlemen. We're kicking it up. All right. Now, that was, let's say this is 8. I'm going to say 9 here. Let's do another example. I'm going to give you, it's just a standard polynomial. Okay? Specifically a quadratic. And we're going to differentiate this quadratic. So derivative of 5x squared plus 3x minus 6. We're going to take that derivative. We're using properties. Derivative of sum and difference is sum and difference of derivatives here. That's a minus. Pull out your constants. 5 d dx of x squared plus 3 d dx of x. And then this is derivative of a constant, ladies and gentlemen, is 0. We're going to use that idea here first. If you don't want to, that's fine, but you're going to do it eventually. Okay, so here's what I'm going to do now. Now that we have some good experience. Power rule. 2x. 1. 0. Since we're kicking up the problems, I want you guys to double check to make sure everything is what it should be. The derivative of x squared is 2x. So your final answer, right? Here's what we're going to say. F prime max becomes 10x plus 3. Okay. Question 10. Give you another quick question here, right? 10. This is a question to see if people are awake. You say, okay, square root of 5x plus the square root of 3x. Let's make that a minus. Okay. So, operator notation. Square root of 5x minus square root of 3x. Derivative of a difference. Difference of derivatives. I bet you we lost that one. Hopefully I remember the right one. 5 and 3. Oh, it's not even there. All right. What number is this? 5 and 3. 10. Okay. Went away. This is something that people need to see, the details. Okay, derivative of a difference is difference of derivatives. Okay. This is going to be kind of interesting. Okay, let's be careful here. Here, maybe we should focus on this. You have to know what that is. The square root of 5x. Now, that's under, I think I want to use red. If you guys remember from intermediate algebra, that's the square root of 5 times the square root of x. Because this line here includes the x. It includes the x. And so that's going to be an important thing. It's different than what you see here. This is a constant times a function. So you can say, I have d dx, the square root of 5, square root of x, minus d dx, the square root of 3x. We can pull out our constants, and when we do, square root of 5 d dx, square root of x, minus the square root of 3 d dx of x. So you're pulling out all the constants, ladies and gentlemen. Now, I'm going to say to you guys here, you also have to remember algebraically that this is x to the 1/2. Okay, that's square root of x. So we can go inside here and say to people, x to the 1/2, ladies and gentlemen. Or, you know, it doesn't have to be red. And I'm also going to say something, I give advice to calculus students, because what happens a lot, I would say to you, you're going to see the derivative of the square root of x a lot. You're going to see this a lot. So I recommend you go through that derivative and find the formula for it. Like certain things, you know, derivative of a constant 0, derivative of x is 1, derivative of x squared 2x. This is another one. You can show that this is 1 over 2 square root of x. And in fact, if you look in your notes, or even some of these examples, we actually might have done this already because it shows up a lot. But you might say, why are you saying this? Because look how fast we can do some of these things, right? 1 over 2 square root of x, 1. So the square root of 5 times 1 over 2 square root of x minus the square root of 3 times a 1. So your final answer is going to be f prime x is the square root of 5, that's a constant, over 2 square root of x minus the square root of 3. And there it is. So having knowledge of some of these derivatives under your belt, ready to go, ready to apply, can save you a tremendous amount of time. Okay, because we just started our derivative career. We're going to do more complicated questions. You know, a question like, for example, that's coming up, what if they give you x squared plus 1 times 3x minus 4, and you look at this and you go, I don't know, what is this? I don't think we've seen anything like that with the tools that we have, right? I'm going to say to you, simplify. And you might say, how? Using algebra. And you might say, algebra? Yeah, remember FOIL. That's not going to ever go away. So, you know, we have x squared plus 1. I'm going to simplify this, right? By first, outer, inner, last. So this is 3x cubed first, outer, minus 4x squared, inner, plus 3x last, minus 4. And I guess that's it. No terms are actually going to what? Combine. So, okay, we did the algebra. And put my operator notation there, right? So now we get to use properties. Derivative of a sum of derivatives, derivative of a difference, difference of derivatives. Now bring out your constants. 3, 4, 3. 3 d dx of x to the third minus 4 d dx of x squared plus 3 d dx of x. Let's move everything over. Minus d dx of 4. Okay. At this point, 3x squared, 2x, 1, 0. We pulled out the constants. So it's very helpful to know those formulas, right? And after a while, you have these derivatives under your belt here. And your final answer. There it is, ladies and gentlemen. So sometimes they give you questions that look like that. And if you said, what if they gave me something that's a lot easier to do, right? You're still going to use algebra. Right? First, outer, inner, last. So you get 5x squared outer. First, outer, that's going to be minus 10x. Inner, plus 3x last. Here's our derivative. properties. Derivative of sum and difference is sum and difference of derivatives. Essentially separate them. Pull out your constant. 5, 7. Now, right, we pulled out all the constants. So we have a 5 here, a negative 7 here, and a minus. Guess what? Differentiate. 2x. 1, 0. 5 times 2x minus 7 times 1. Let's get the computer back. Minus 0. F prime x is 10x minus 7. And there it is, ladies and gentlemen. 10x minus 7. You know, it's where we simply use our multiplication skills, FOIL, beginning algebra skills. Let's give you another function. How about if they give us x squared minus x to the minus 2 power x plus x to the minus 3 power. Let's double check to see. Yeah. Oh, I guess I have to tighten this. I don't know what's going on here. I gotta look that up. All right. Again, you say FOIL. First terms, x cubed. Outer terms, and maybe I have to go through more steps here. X squared times x. First term, outer. X squared times x to the minus 3, inner. Minus x to the minus 2 times x. And last terms. So double check. I wish you guys can double check. I wish you were here. Last terms. Minus x to the minus 2. X to the minus 3. So double check we did FOIL. I'm sure I'll hear about it from you guys. Okay, so x cubed plus x to the minus 1 minus x to the, well, that's going to be a minus 1, right? Because you got the power 1 there. You guys know what I'm talking about? Okay. And this will be minus x to the minus 5 here. So this is going to be a good question, I think. Let's see. Combine like terms. X cubed. Oh, these are 0. These are gone. Minus x to the minus 5. So double check my algebra. Okay. And there it is. Derivative of a difference. Difference of derivatives. All right. And as you guys can see now, power rule for both. 3x squared minus negative 5x to the negative 5 minus 1. Maybe you guys need to see that still. I don't know. Okay, so let's go over every detail. 3x squared plus 5x to the minus 6 power. So you're doing some algebra, opposite of an opposite, and subtracting. You know, that's pre-algebra, by the way. And then beginning algebra, writing with a positive exponent, x to the minus 6. Okay, so notice that, right? F prime x is 3x squared plus 5 over x to the 6th power. So notice what I'm saying here to people is, you know, you're going to have to get tutored by your younger brothers and sisters in like pre-algebra or beginning algebra, and even some very small, minute intermediate algebra. Anyway. All right, let's do one for the road. We don't want to stop on 13 anyway. That's an unlucky number, right? 14. Square root of x times x minus 8. And you say, Mr. Judge, we don't have to use FOIL. We just distribute, right? Yep. Use some algebra. Square root of x times x minus 8 square root of x. And you say, is this x to the 1/2 times x to the 1st minus 8 times x to the 1/2 power? It is. And x to the 1/2 plus 1 minus, right, x to the 1/2. And you guys know this will give you x to the 3/2 minus 8x to the 1/2. Just doing some arithmetic. Don't forget to differentiate. And you're differentiating a difference. Pull out your constant. So, you know, this is all the properties right? We pulled out the constant, ladies and gentlemen. Okay, power rule now for these, for both of these. Say why? Because you have a power x to the 3/2, x to the 1/2. And I'm gonna say to you guys, I'm gonna do this. Take a look. Remember what I said? Shows up a lot. 1/2 square root of x. I already got that one out of the way. I just now have to get the next one. So power rule for the first one there. 3/2 x to the 3/2 minus 1. There's my power rule. Minus 8 times 1/2 square root of x. So I'm bringing it down so I don't forget. Now, 3/2 minus 1 is really 3/2 minus 2/2, because 2/2 is 1. So notice what we have here. We get 3/2 x to the 1/2 minus, and then 8 divided by 2, that's 4 over square root of x. Here we go, ladies and gentlemen. At this point, guess what? F prime x will be 3/2 square root of x minus 4 over square root of x. And you're done. So this is 14. Maybe I think of one more, 15. I kind of like that. I don't know why. Multiple of 5s. And maybe we'll give you a trick question here. Yeah. A lot of fun examples to do, actually. They can say, what if you have 5x squared plus 8x divided by x? I know, you say, this is too easy. Can you make it harder? Okay. 4th power. All right. And then we'll give this a power like a 3rd power, and then give this a 2nd power, and then it looks even more scarier. Again, use algebra. What do you mean? Well, the x squared term is dividing two terms. It's dividing a sum, okay? Since it's dividing a sum, we distribute the division. Notice what this is. This is beginning algebra, ladies and gentlemen. So we get 5x squared plus 8x derivative of a sum of derivatives. Alrighty. Constant. Pull out your constants. 5 d dx of x squared plus 8 d dx of x. 5 and 8. And now you say power rule. 2x, 1. So you get 5 times 2x, ladies and gentlemen, plus 8 times 1. Here is your final answer. F prime x will be 10x plus 8. So, ladies and gentlemen, they gave you this quotient here. And in all honesty, a lot of these questions, like the products here, so they gave you a quotient originally and you get scared and you go, oh my God, how do I differentiate that? Well, there's a way. It's right here. You're able to do some beginning algebra division, and you even can do beginning algebra-ish kind of multiplication. They give you a product here. It's distributive property. It starts to become intermediate algebra because of the radical, right? You don't study radicals in beginning algebra, but intermediate algebra you do. Here's kind of a beginning algebra question too. So, you know, FOIL, beginning algebra. So the algebra that you have coming back, ladies and gentlemen, is extremely important, okay? This is a part of the course. Don't look at a calculus course and go, oh, you know what, it must be a course. I want to just study calculus. I don't want to think of the algebra or trig. I don't want to think of the last courses. I didn't have much success there anyway. I'm glad I'm not in them. I'm in calculus. Can you just show me calculus? And I'll tell you, this is the calculus, ladies and gentlemen. This is it. Now, there's other concepts that we're going to look at, but, you know, to say you can't do it without actually doing the algebra. So I wanted to give you guys this morning, like I promised, some additional examples. So I gave you about 45 minutes of examples of derivatives and 45 minutes of the differentiability examples that we worked on this week. So here you guys go, and I'll contact you guys via email about these when they're uploaded. Have a great day. Take it easy. Stay safe.